Right. So this is my lab report 1. In lab 1, we focus on constant velocity. We observe an object that is going at constant velocity without changing directions. We get to use Newton's second law and see how it's centered around net force and forces acting on it. During our experiment, we compare observed motion and predicted motion of an object that is used during the experiment. We use a position versus time graph. The results shown are that the predicted slope is more linear than the experimental slope in the graphs. With Newton's second law, it can be defined as velocity final is equal to velocity initial plus net force over mass times the change in time. Since velocity is constant, we get velocity final is equal to velocity initial, meaning that F net is equal to 0. This means that forces acting on the system cancel out, getting us velocity final is equal to velocity initial. Since F net is equal to 0, we can use the position equation. R final is equal to R initial plus velocity times the change in time. So we can go to tracker. In our experiment, we rolled an object and used tracker to see different positions that our object was in. We use these points marked to plot our graph to demonstrate the observed data as shown. When it comes to calculating the initial position, we can use the actual initial position or the average initial position. As shown, we calculated our initial position and got 3.83 meters per second when we used only the first data point. This is less accurate because we're only using one of the data points rather than when we use average initial position. We calculate using the final position minus the initial position and divide it by the final time minus the initial time, which gave us 6.73 meters per second. It's more accurate since it gives us the final and initial position points. We got all of our data from our video analysis of the object motion shown. So that was from Tracker. As we go to the Glow script in our Python code, I used the information that we gathered from Tracker and I made it into so that our second is our initial position and our velocity is the average initial velocity that we had that we calculated. So when we run the program, this is what we get. Okay. So the graph demonstrates the position versus time, series 1 being the observed data and series 2 being the predicted data. As you can tell by the graph, the observed data isn't exactly linear, but it still follows that positive linear trend that the predicted data follows. Real speed is not constant because there are forces that come into play, and this is why the observed data isn't exactly linear as our predicted data. With the flipped x-axis, I just changed the signs of the slope to be negative. The only thing that really changed was that the object would be traveling to the left rather than the right. So the points are basically the same, just in the negative direction, meaning that it would be going to the left. With the zero net force, it's difficult to say exactly how many forces are coming into play to make the F net 0. We can notice some forces such as gravity, friction, the force of the object on the table, and the force of the table onto the object. Alright, thank you for watching.